Welcome, learners. Let's continue the topics in Solidity programming language. Today, we will talk about the Solidity assembly. Solidity assembly is a feature in Solidity programming language that allows you to write low-level assembly code directly within your smart contract source code. So assembly language is a low-level programming language that is closely tied to underlying machine architecture and can be converted into machine code using an assembler. So in the context of Solidity, assembly refers to the Ethereum virtual machine assembly, which consists of opcodes that represent the fundamental operations performed by EVM, Ethereum Virtual Machine. These opcodes can be used to interact directly with the EVM and perform tasks that may not be possible or efficient using only Solidity. So by using Solidity assembly, you can have more fine-grained control over the execution of your contract and access certain features that are not exposed by the Solidity language itself. For example, you can directly manipulate memory, perform bitwise operations, access and manipulate storage slots, interact with external contracts, and more. So Solidity assembly allows you to write, optimize, and efficient code by directly utilizing the EVM opcodes. However, it's important to note that writing assembly code requires a deep understanding to the EVM and low-level programming concepts. It's generally recommended to use assembly only when necessary and when you need to achieve a specific optimization or interact with low-level features. An important use case of Solidity assembly is accessing a specific memory blocks. So Solidity doesn't provide direct memory management capabilities, but with assembly, you can work with the specific memory addresses and manipulate memory directly. So Solidity assembly provides a way to write low-level code within your Solidity smart contract, giving you more control and flexibility in certain scenarios. However, it should be used with caution and only when necessary, okay? As incorrect usage of assembly can introduce security vulnerabilities and make your code harder to understand and maintain. One of the main advantages of using assembly in Solidity is that can help reduce the gas cost of deploying contract. So gas is the unit of computation of the Ethereum network, and each operation in a smart contract consumes a certain amount of gas. By writing assembly code, you can have more control over the execution and optimize your code to reduce gas costs. So Solidity provides two ways to implement assembly language. We have here inline assembly and a standalone assembly. About the inline assembly, we will, inshallah, apply some code for inline assembly and a standalone assembly. So inline assembly allows you to write assembly code directly within your Solidity code. It provides fine-grained control and is often used to enhance the language by creating new libraries or implementing advanced optimizations. So inline assembly code can be inserted in between Solidity statements, and the EVM can understand it and execute it. Okay, so this allows you to use assembly features such as local variables, function calls, switch statements, if statements, loops, and more. So inline assembly is particularly useful when the Solidity optimizer is not able to produce efficient code on its own. What about standalone assembly? Standalone assembly was originally planned to be an intermediate language for the Solidity compiler. It was supported for compatibility reasons in the past, but it is no longer actively documented in Solidity documentation. Okay, so programs written in a standalone assembly should have readable code, even if it's generated by Solidity compiler. It's mainly used for control of flow, optimization, and formal verification purposes. However, it's important to note that standalone assembly is less commonly used compared to inline assembly. Okay, so both inline assembly and standalone assembly provide ways to write low-level code in Solidity and give you more control over the execution and optimization of your smart contracts. However, it's important to use assembly and only when necessary, actually, as it introduces complexity and requires a deep understanding of the Ethereum virtual machine and low-level programming concepts. Let's see this example. In this code, a Solidity contract demonstrate the usage of inline assembly. Let's break down the code and explain each part line by line, but I will explain it on the environment here. So this code means SPDX. As we said previously, license identifier for the contract and set the Solidity compiler version to be used. Let's go to the function add here. Okay, this part. Okay, this code defines a contract named inline assembly and declares a function named add. Okay, the function takes an unsigned integer parameter A and return an unsigned integer parameter B. So the purpose of this function is to demonstrate the usage of inline assembly in Solidity. Inside this function, the inline assembly code written using the assembly keyword. This is the keyword, using the assembly keyword. So inline assembly allows you to write low-level code directly in Solidity by using the EVM opcodes, okay? The inline assembly code performs here the following steps. It creates creates a new local variable, which is C, okay, this line 15, and calculate the sum of A and 16 using the add opcode. The result is assigned to what? To C, okay. Then it uses the mstore opcode to store the value of C in memory at the memory address 0x80. Okay, 0x80. So this is to store the value of C. About the next here, it creates a new local variable D here, a new local variable D, and calculate the sum of the value loaded from the storage at the address C and 12 using the add opcode. The result is assigned where? Assigned to D. Okay. Then here it assigns the value of D, okay, to the function return variable B. This is the meaning of line 30. Again, assigns the value of D to the function return variable B. Then here we have, or we can say the inner block of assembly code is exited here, and D is deallocated. Okay, it calculates the sum of B and C using the add opcode and assigns the result back to B. Okay, the outer block of assembly code is exited here, and the C is deallocated also. Okay, so the function returns the final value of B. Inline assembly actually is a powerful feature of Solidity that allows you to write the low-level code when necessary. However, it should be used with caution, as it bypasses many of the safety checks provided by the Solidity compiler and can introduce security risks if not used correctly. Let's compile this code. And then we go to the deploy, but at the first, okay, then deploy it. We can see here, we should here add, okay, add the number for A. Let's put 10, like this example. 10, and we got the result of B, which is 38. It's the it's this means 10 plus 16 plus 12, and the result will be 38. Okay. Now let's talk about the standalone assembly and this example in the IDE. I wrote it here to see the code line by line. Okay, let's go to the this part. So this code defines a contract named standalone assembly. The purpose of this contract is to demonstrate the usage of a standalone assembly in Solidity. Inside the contract, there is a function named add. This is the function. The function takes an unsigned integer parameter A and returns an unsigned integer B. And the function is declared as a pure, indicating that it doesn't read from or modify the contract's state. So the function initializes the variable B with the value 10, okay? Then it executes a for loop with the loop variable n initialized to 0, as you see here. The loop continuous as long as n is less than a. In each iteration, the value of b is updated by adding a to it. So this means that the value of b will be what? Incremented, okay? By what? By a, so a total of a times. Finally, function returns the final value of b. So standalone assembly concepts allows you to write a low-level code also inside Solidity function. It can be useful in certain cases where fine-grained control over the Ethereum virtual machine instructions is required. It's important to note that standalone assembly should be used with caution, as it bypasses many of the safety checks provided by the Solidity compiler and can introduce security risks if not used correctly. Let's deploy this code. Before deploy, we should compile it, then deploy this code and go to the here and add the number. Actually, let's write, okay, here we have 16. I will add 16. Then we got 266. Let's add 20. Okay. Or we can say 4. We got the result 26. Okay. So this is the information about the assembly and the two types of assembly, inline and standalone, and we learned the differences between those types and what is the purpose of using assembly here, and the key features for this. Thank you for watching this video. I hope it's helpful. This video helpful to I hope this video actually help you to understand why we use assembly in Solidity and other programming languages. Thank you for watching.